Hello and welcome to The Most Significant Bit, a podcast that explores the connections between engineering, technology, humanities, and the arts. I'm your host, Ryan Stack, and today we will be diving into the fascinating world of solar panels and their incredible impact on the world. We'll also uncover how these technological marvels are inspired by the natural world through biomimicry, specifically how they mimic plants and flowers. Let's dive into the origins of photovoltaic technology. It all started back in 1839 when a French scientist named Edmond Becquerel discovered the photovoltaic effect while experimenting with an electrolytic cell made up of two metal electrodes placed in a conductive solution. He observed that the cell produced more electricity when exposed to light. This was a game changer which set the stage for the future of solar technology and how we could use it to generate electricity. Now fast forward to the mid-20th century, and we find scientists at Bell Labs creating the first solar cell capable of converting enough sunlight into power to run everyday electrical equipment. This groundbreaking invention marked a significant advancement in photovoltaic technology. The Bell Labs team was inspired by the concept of artificial photosynthesis, a process akin to how plants convert sunlight into energy. Their work laid the foundation for the modern solar industry, demonstrating that solar energy could be and is a viable source of power for practical applications. Now, at the core of photovoltaic technology is the photoelectric effect and the use of semiconductors and p-n junctions. Heinrich Hertz in 1887 discovered that ultraviolet light could alter the voltage required to cause a spark between two metal electrodes. This discovery was crucial for Albert Einstein's later work, which explained the photoelectric effect and earned him a Nobel Prize in 1921. Einstein's work provided a theoretical framework for understanding how light can generate electricity, a concept that is fundamental to how solar panels operate. When sunlight hits a semiconductor material in a solar cell, it excites electrons, creating an electric current. Over the years, numerous breakthroughs have made this process remarkably efficient, enabling solar panels to convert sunlight into electricity with increasing effectiveness. The photoelectric effect and the advances made in semiconductor technology are at the heart of how solar panels work, demonstrating just how far we have come in understanding light and electricity. But here's where it gets really interesting. Solar technology takes and uses many ideas from nature. Similar to the way plants and flowers have evolved to capture sunlight efficiently, solar panels have adopted these strategies. One such example of innovation in solar technology are the dye-sensitized solar cells. These cells have a protective coating inspired by the microstructures on flower petals. These structures reduce glare and enhance color, boosting the efficiency of light absorption. This approach allows solar cells to capture more sunlight and convert it into electricity more effectively. Another neat trick that solar panels use is angle optimization, which is the process of solar panels angling themselves towards the sun so they can track the sun's movement, much like sunflowers do. This angle optimization increases their efficiency by ensuring they capture the maximum amount of sunlight throughout the day. Bifacial panels take it just a step further by absorbing light from both sides, capturing direct sunlight from the front and reflected light from the rear, further enhancing their energy generating capacity. The latest advancements in solar technology have seamlessly integrated these systems into our daily lives. Take solar roofing, for instance. These solar shingles represent a sleek yet efficient solution for residential energy needs. The solar shingles look like traditional roofing material but function as solar panels, providing a simple yet effective truce of energy generation in home design. Now in agriculture, solar-powered irrigation systems are revolutionizing how farmers manage water resources. By harnessing solar energy, these systems reduce dependency on fossil fuels and provide a sustainable solution for irrigation, especially in remote areas lacking traditional power infrastructure. This application of solar technology is helping to promote sustainable farming practices and improve food security in many parts of the world. The benefits of solar technology are huge. With increased efficiency and lower costs, renewable energy is becoming more accessible and economically viable. As solar panel technology continues to advance, the cost of solar energy continues to drop, making it an increasingly attractive option for homeowners, businesses, and governments alike. Environmentally, solar panels significantly reduce our dependence on fossil fuels, contributing to a cleaner and greener planet. By generating electricity from sunlight, we can reduce greenhouse gas emissions and mitigate the impacts of climate change. Companies like First Solar and SunPower are leading the charge in producing advanced solar panels. Their innovations are not only powering urban areas with established infrastructure, but also bringing electricity to remote regions where traditional power sources are just unavailable. These companies are at the forefront of the renewable energy revolution, and they're driving the transition to a more sustainable energy future. Today, we've explored how solar panels exemplify biomimicry in nature, and how advancements in photoelectricity and solar technology are transforming industries and lives. From residential to industrial applications, solar energy is reshaping how we generate and consume power. Thank you for joining us on this enlightening journey. I'm Ryan Stack, and this has been The Most Significant Bit.